Welcome to EducAgent Studio, where a crew of AI agents help us teach, and you learn with ease. Here's the problem we'll solve today. Forward elimination changes the system 1, 1, 1, 2, x equals b into the upper triangular system 1, 1, 0, 1, x equals c, as shown by the equations and augmented matrices. Your task is to fill in the blanks. Identify the elimination multiplier L21. Write the reverse step matrix L that undoes elimination. Multiply L times ux equals c to recover the original system, and then state that relationship in letters. The elimination multiplier is what we multiply row 1 by to cancel the entry under the pivot. Here it's 1 over 1, so L21 equals 1. That fills in the first blank. The multiplier is 1. Elimination performs one key row operation. Subtract L21 times row 1 from row 2. Since L21 equals 1, we just subtract row 1 once. Watch the lower left entry, 1, turn into 0, and the right-hand side 7 turn into 2. The row operation can be packaged as a matrix E that performs row 2 minus L21 row 1. Plugging in L21 equals 1 gives the specific elimination matrix. To undo elimination, we do the opposite row operation. Add back what we subtracted. The inverse of the elimination matrix is called L, and it contains the multiplier with a plus sign. With L21 equals 1, the reverse step matrix is L equals 1, 0, 1, 1. After elimination, we're left with the triangular system ux equals c. Now we'll multiply both sides by L to rebuild the original system. First, multiply the matrices on the left. L times u. This product reconstructs the original coefficient matrix. Now do the same multiplication to the right-hand side vector. The original right-hand side b is recovered. b equals lc. Multiplying ux equals c by L gives lux equals lc. So the filled-in equation is exactly the original system matrix and original right-hand side, using the same unknown vector x. In general letters, we start from the triangular system. Multiplying both sides by L produces lux equals lc. This is the compact statement. A equals lu and b equals lc, so the original system is ax equals b. Elimination uses E to go from A to U and from B to C. The reverse matrix L equals E inverse brings us back from U to A and from C back to B. The multiplier is 1, and it appears below the diagonal of L. One quick multiplication confirms we recovered the original matrix and right-hand side. Watch the next one to see how these same undo ideas scale up. More rows, more multipliers, and a full LU factorization you can actually use.